on physics. Today, I would like to teach you a topic current electricity. Actually, this topic is very easy to understand, but the problem asked in the exam are some tricky. So, in this today's lecture, we'll try to solve the various tricky questions which has been asked in the MST CET exam as well as JEE main exam. So let we start. You look at the first example. The first example is based on Wheatstone Bridge. All of you know about the Wheatstone Bridge. So what is the use of the Wheatstone Bridge? The Wheatstone Bridge is used to measure unknown resistance. And the example is given in a Wheatstone bridge, three resistances P, Q, and R are connected in the three arms. And the fourth arm is formed by two resistances S1 and S2 connected in parallel. And the condition for the bridge is balanced. The bridge is balanced. And question is, what is the ratio of P to Q? That question is asked. This example is very easy. So let me solve this example. You know the Wheatstone bridge. The Wheatstone bridge consists of four branches like this. And these are connected in bridge. That's why the name is given the Wheatstone bridge. And there is one galvanometer between these two ends. The galvanometer is used to detect the current which is flowing through the this branch from this point to this point. Let's consider here the resistance P is connected, here resistance Q is connected, R is connected, and in the fourth branch, the parallel combination of S1 and S2 are connected. The parallel network is present there in the fourth branch, where S1 and S2 are in parallel. And also you know that if S1 and S2 are in parallel, then the total resistance is S1 into S2 divided by S1 plus S2. This equation we got by using the sum of the reciprocal of the individual resistance. So how it can be calculated? 1 upon equivalent resistance is equal to 1 upon S1 plus 1 upon S2, where S1 and S2 are connected in parallel. After solving this equation, we'll get this one. S1 S2 divided by S1 plus S2. Now what is the condition for balanced bridge? The bridge is balanced. The bridge is balanced if ratio P to Q is equal to ratio R upon S. This is a condition for balanced bridge. I will write here the condition for balanced bridge is P divided by Q is equal to R divided by S, where S be the parallel combination of S1 and S2. So what is S? The parallel combination of S1 and S2 is product of S1 S2 divided by sum of S1 S2. So you can replace S by this term and we'll get the P upon Q is equal to R divided by S1 S2, and this S1 plus S2 will come at numerator. S1 plus S2. So correct answer P by Q is R into S1 plus S2 divided by S1 S2. So which is the correct answer? This, the option A is the correct answer. In this example, you need to remind the condition for balanced circuit. The condition for balanced circuit is P upon Q is equal to R upon S, where PQ RS are connected in bridge like this. This one is a P, Q, R and S, and the gallon meter is connected between these two extreme ends, and under the balance condition no current will flow through the branch. I is equal to 0. So we can say P and R are in series, P and S are in series. In this way you may solve the example. It's very easy. It is asked in MST CT 2014 exam. Now let we solve the second example. It is also based on the bridge circuit. It's very simple. The example is given as follow. In the following network, the current flowing through the 15 ohm resistance is. So what is the current flowing through 15 ohm resistance that we have to find? Let's consider the current flowing through the 15 ohm resistance is I. Now under the balance condition, if the circuit is balanced, then you can say there is no current flowing through the circuit. This is a gallon meter. But we have to check either the circuit is a balance or not. So what is the condition for balance circuit? The 15 divided by 20, you check the condition for balance. Condition for balance circuit. The 15 divided by 20 is equal to 3 divided by 4. 3 divided by 4. Now you know the 5 threes are 15 and 5 fours are 20. So this will be 3 by 4 is equal to 3 by 4. So we can say the Wheatstone bridge is a balanced. What is the conclusion? The Wheatstone bridge is a balanced. And this has been checked with help of this equation. 15 upon 20 is equal to 3 upon. And as the circuit is a balance, there is no current flowing through BD branch. The current is 0. It means that the whatever current flowing through the 50 ohm, the same current will flow in the 3 ohm. The same current I will be flow in 50 and 3 ohm. It means that 15 ohm resistor and 3 ohm resistor are in series. So we have got a new circuit under the balance condition. The 15 and 3 are in series. It become 18 ohm. 15 plus 3 is 18 ohm, and 20 and 4 are also in series because the same current will flow in 4 ohm and 20 ohm because there is no current in the gallon meter. So 20 plus 4 is 24. So 24 ohm resistor connected across the 18 ohm. Now the total current flowing in the circuit is 2.1 ampere, and we have to find the current flowing in 15 ohm, or you may find the current flowing in the 80 ohm because the same current is flowing. We have to find the I. Now how the current I can be determined using current divider formula? You keep in mind how to determine I using current divider formula. The current divider formula you have to remind. Let me write. The current flowing through the 18 ohm is equal to total current. The total current is 2.1 into opposite resistor. The opposite resistor is 24 divided by sum of resistances which are connected in parallel. It becomes 18 plus 24. Are you getting? So that is the equation we got according to current divider formula. Once again, I repeat, the current flowing through the 18 ohm is equal to total current 2.1 into opposite resistor. We have to find the current in 18 ohm. And opposite resistor to 18 ohm is 24 ohm. Divided by sum of resistances which are connected in parallel. 18 plus 24. Now you solve this example. 2.1 into 24 divided by 24 plus 18. It become 42. Isn't it? And simplify, you solve this sum equation. 2.1 into 24 divided by 42. You know, 6 fours are 6 into 4 is 24 and 6 into 7 is 42. It become 8.4 divided by 7. 8.4 divided by 7 is 7 ones are 1, 7, remainder is 1.7 twos are 14. So answer is 1.2 ampere. The current flowing through 15 ohm resistor is 1.2 ampere. So option C is correct option. So in this example, once again I repeat, first of all you have to check either the bridge is balanced or unbalanced. If the bridge is balanced, then no current flowing through the branch BD. The same current will flow through 15 ohm and 3 ohm. And the same current will flow in 4 and 20 ohm. And there is a parallel combination of 18 ohm and 24 ohm. Then use current divider formula. The current divider formula says the total current into opposite resistor 24 divided by 18 plus 24. Suppose sometime if you have been asked to determine the current in 24, how it can be calculated? The total current into 18 divided by 18 plus 24. Let's consider the current flowing through the 24 is I1. According to current divider formula, it would be a 2.1 total current into opposite resistor 18 divided by 18 plus 24. So in this way you determine the current in any branch. Let we move to the next example. The next example is also based on the meter bridge. It is equivalent to the balance bridge circuit or Wheatstone bridge, we can say. The example is given on the meter bridge. The resistance in left and right gap of the meter bridge are 20 ohm and 30 ohm respectively. When the resistance in the left gap is reduced to half its value, then the balance point shifted by. Here the two conditions are given. So let me draw first the bridge circuit, meter bridge circuit. All of you are aware about the meter bridge circuit. And in fact, you might be done the experiment on the meter bridge in the lab. This is your meter bridge circuit. At the left gap, there are two gaps here, left gap and right gap. At the left gap, the 20 ohm resistor is connected. And at the right gap, 30 ohm resistor is connected. And here the conducting wire is connected between these two copper strips. And the length of the wire, conducting wire is 1 meter, or we can say 100 centimeter. That's why the name is given meter bridge. The length of wire is 1 meter. And 1 gallon meter is connected with help of jockey to the wire. The gallon meter is connected here with help of jockey. And if the meter bridge is balanced, there is no current here. In the first case, let's consider the null point occur at point X, and this length will be X or it's a L guy, L. Instead of X, you let consider L. L be the location of the null point, and the total length is 100 centimeter. So this length at the right hand side must be 100 minus L centimeter, isn't it? Now the first condition is given: the resistance in the left and the right gap of the meter bridge are 20 and 30 ohm respectively. When now for this condition, you may write the equation 20 divided by L is equal to 30 divided by 100 minus L. After solving this equation, we'll get 2000 minus 20L. You take cross multiplication is equal to 30L. So 2000 is equal to 50L. This gives 50L is equal to 2000. And what is L? 2000 divided by 50. 2000 divided by 50 gives 40 centimeter. So what is the location of the null point for the first case? At 40 centimeter, your meter bridge is a balanced bridge, isn't it? Now the second condition given, now you read out the second condition: when the resistance in the left gap is reduced to half its value, then what is the position of the null? New position you have to find. Now the condition is given: the left resistance is reduced by half. It means it become 10. Then what would be the position of the new? Let's consider new position is L1 is equal to 30. The right resistance is not changing. 100 minus L1. So it become 1000 minus 10 L1 is equal to 30 L1. You solve this, minus 10 L1 will come at the right hand side. It become 40 L1 is equal to 1000. So L1 is equal to 1000 divided by 40, and it is equal to INR 1000 divided by 40 or 100 divided by 4 gives 25 centimeter. Now look at the solution of the first case. When the left is 20 and right is 30 ohm resistor, then balance point is located at 40 centimeter. But when the left resistor is reduced by half, then balance point is changed. Now it become 25. It means it shifted towards the left by 15 centimeter. What is the difference between 40 and 25? Difference is 15. And we are always measuring the distance from the left hand side, from this end, from left end. It means that when the left resistor is reduced by half, then the null position is shifted by 15 centimeter to the left, isn't it? So option B is correct. So in this way you may solve the example. The prerequisite for solving this example is you should know the construction of the meter bridge circuit and condition for the balance bridge. This is a condition for balance bridge. 20 divided by L is equal to 30 divided by 100 minus L, where L be the location of the null point, or you may call it as a location of the balanced circuit. Let we move to the next example. Example number 4. Here in this example, two unknown resistances are connected in two gaps of the meter bridge. The null point is obtained at 40 centimeter from the left end. A 30 ohm resistance is connected in series with the smaller of the two resistances. Then null point shifts by 20 centimeter to the right. Then the value of the smaller resistance in ohm. What is the value of the smaller resistance? You have to find. The first condition is given. Let's consider the unknown resistance is R. The left resistance is unknown resistance. R is unknown resistance. R is unknown. Isn't it? And the condition is R divided by 40. The null point is 40 is equal to S divided by 100 minus 40. The what is the location at the right? 100 minus 40. It means 60. Are you getting? As far as first condition is, first case is concerned, the condition for the balance is R upon 40 is equal to S upon 60, where R is the unknown resistance connected at left hand side, and S is unknown. S is also unknown, but connected at right hand side. After solving this condition, we can get the relation for R and S. Cancel the 0, 0, then it will become 6R is equal to 4S, or 3R is equal to 2S. So that is the first relation we got after applying first case. Now read the second case. Now a 30 ohm resistance is connected in series with the smaller resistor. आता ह्याच्यामध्ये तुम्हाला स्मॉलर रेजिस्टर कुठला हे समजेल. The 3 times R is equal to 2 times S. So which one is the smaller? R must be smaller. Are you getting? So R is equal to what? R is equal to 2 divided by 3 into S, where 2 by 3 is less than 1. So R must be smaller and S is greater. So with help of this condition, we can say R is less than S. Isn't it? And in the second case, we have given a 30 ohm resistance is connected in series with the smaller resistance. It means the 30 ohm is connected in series with R. Then null point shift to 20 centimeter to the right end. Isn't it? So what is the second case? When 30 ohm resistance is connected in series, then null point is shifted 20 centimeter towards the right, towards the right hand side. The original position was 40 and 20 centimeter is added, it becomes 60 is equal to S divided by, now here there will be 40 because 60 plus 40 is 100 centimeter. And solve this example with help of this equation. This will be R into 40 is equal to plus 30 into 40 is equal to 60S. So this will be 40R plus 1200 is equal to 60S. Now divide by 10, we get 4R plus 120 is equal to 6S. Again divided by 2, it becomes 2R plus 60 is equal to 3s. Are you getting? Now we know the relation for R in terms of S. So what is it? 3R is equal to 2S. 3R is equal to 2S. So you can replace this S by, what is S? S is equal to 3 by 2R. S is equal to 3 by 2R. And the new equation become 2R plus 60 is equal to 9R divided by 2. Again simplify it, it become 4R. You take 2 at the left hand side, it become 4R plus 120 is equal to 9R. Then take 4R at the right hand side, it become 9 minus 4 is 5. 5R is equal to 120. And then find R. 120 divided by 5. So what will be the answer? 5 twos are 10 and 5 fours are 20. It become, the answer is 24. So what is the unknown resistance? R is 24 ohm. So what is the option? You look at the options. A is 12, B 24. 24 is the correct answer. The option B is correct. So for this example, you should remind the condition for the balanced circuit. And the two cases have been applied. The first case is R upon 40 is equal to S upon 60. And second case is R plus 30 divided by 60 is equal to S upon 40. Then using these two conditions, you find the unknown R and S. The sixth example is given. It is based on the meter bridge. You read out. A meter bridge is set up as shown in figure to determine an unknown resistance X. The unknown resistance X is connected at the left hand side and the 10 ohm resistance is connected at the right hand side. The gallon meter shows a null point when tapping key is 52 centimeter mark. The null point is given at 52 centimeter. The end corrections are given 1 centimeter and 2 centimeter respectively. It means you have to add 1 centimeter at the left hand side reading and 2 centimeter at right hand side reading. And you have to find the X. Very simple. Actually, you know the condition for balance bridge. X divided by L, where L be the location of the null, is equal to 10 divided by 100 minus L. 100 minus L. But the corrections are given. The 1 centimeter and 2 centimeter respectively for the ends, left hand and right hand. You can modify this condition. The location of the null is given 52 and plus you have to add 1 centimeter correction is equal to 10 divided by 100 minus 52 plus 2 centimeter correction at the right hand side. After solving, it become X upon 53 is equal to 10 upon 100 minus 52 plus 2. 100 minus 50, it become 50. And then find X. What is X? X is equal to 10 into 53 divided by 50. 53 divided by 50 is the unknown resistance. Multiply by 10. Then solve it. 10 5 is a 50, and this will become 5.3. It will 5 twos are 10, 5 ones are 5. It will be 2 into 5.3, or it is 10.6. The unknown resistance is 10.6. The options are given. The first option is 10.2. It is incorrect actually, because the correction you have to add 1 centimeter and 2 centimeter respectively at left and right hand side. But if there is no correction, then answer 10.2 would be the correct answer. But here corrections are added. So 10.6 is the correct answer. Okay. So in this way, you solve the example on the meter bridge. The sixth example is a tricky example. It is asked in the JEE Main 2018. It's a very easy but tricky. You have to think over and over to solve this example. So what is the example given? On interchanging the resistance, the balance point of the meter bridge shift to left by 10 centimeter. The resistance of their series combination is 1 kilo ohm. And how much was the resistance on the left slot before the interchanging the resistance? So how to solve this example? We let consider R1 and R2 are two unknown resistances. R1 is unknown and R2 is also unknown. R1 is connected at left hand side and R2 is connected at right hand side. But summation of these two resistances are given. The sum of R1 and R2. Sum of R1 and R2 is 1 kilo ohm, or we can say 1000 ohm. Now with help of this relation, we can find the relation for R2. R2 is equal to 1000 minus R1. Isn't it? Now, the first condition you can draw here. In the first case, let's consider R1 is located at left hand. R1 is connected at left hand and R2 is connected at right hand, where R2 is known. R2 is 1000 minus R1. And this will be the meter bridge. The length of wire, 100 centimeter. The total length is 100 centimeter. The total length, how much? 100 centimeter. And you can locate a gallanometer point with help of jockey. Let's consider the balance or null point is L, or you may say L1. L1. And the length of total wire is 100 centimeter. This must be 100 minus L1. So for the first case, under the balance condition, the equation is R1 divided by L1 is equal to 1000 minus R1 divided by 100 minus L1. हे कंडिशन मिळणार तुम्हाला. Are you getting? After simplifying this equation, we get, you take a cross multiplication, it become 100 R1 minus R1 L1 is equal to 1000 L1 minus R1 L1. Minus R1 L1 minus R1 L1 from left and right side will be cancelled, and we'll get the equation 100 R1 minus 1000 L1 is equal to 0. So that would be equation number 1. Is it right? Equation number 1 असणार आहे. The equation number 2 can be obtained with help of second condition. Now in the second case, the resistances are interchanged. Now at the left side the R1, left side 1000 minus R1 is connected, and at the right hand side R1 is connected to the meter bridge. And now the location is changed. The location is changed. When the resistances are interchanged, the balance point of the meter bridge shift to the left hand side by 10 centimeter. So new location would be, this will be L1 minus 10, and the length of the right hand side would be 100 minus L1 minus 10, or 100 minus you write in this way, 100 minus L1 minus 10, or you may write 110 minus L1, isn't it? And apply the condition for balance, it become 1000 minus R1 divided by L1 minus 10 is equal to R1 divided by 110 minus L1. Then take cross multiplication, we'll get 110 into 1000 gives 1 followed by 4 zeros, minus R1 into L1, minus R1 into L1, then minus 110 into R1, minus 110 into R1, and plus R1 into, this will become plus, sorry, not minus. Minus R1 into minus L1 is plus R1 L1. First multiply 110 with 1000, we get this one. Then multiply minus L1 with minus R1, it become R1 L1. Then multiply 110 with minus R1, it gives minus 110 R1, and multiply this minus L1 to 1000, it gives minus 1000 L1 is equal to R1 L1 minus 10 R1. Now R1 L1 and R1 L1 from both sides will be cancelled. Then minus 110 R1 and this one minus 10 R1. You take a minus 10 R1 at the left hand side, it gives minus 100 R1. Minus 1000 L1 is equal to minus 11 followed by 4 zeros. Then change the sign. The second equation is 100 R1, 1000 L1, and 110,000. Now you can solve these two equations. It's very easy. Take the summation. You will get summation of these two equations. 100 R1 plus 100 R1 gives 200 R1. Minus 1000 L1 plus 1000 L1 will be cancelled, is equal to 110,000. Then find R1. R1 is equal to 110 0 divided by 200. So these 2 are cancelled. 1100 divided by 2. 1100 divided by 2 gives 550 ohm. So in this way you find the R1. R1 is 550 ohm. What is the correct answer? The 550 ohm resistance is the correct answer. The question was very simple, but some confusion was added. The trickiness, and that you have to solve. You must have the capacity to solve these tricky questions. But the overall thing you may observe, the mathematical calculation, all those things are very simple. You have to apply your logic, then only you can solve. The next example is based on the bridge circuit. The example number 7. In the balance meter bridge, the resistance of bridge wire is 0.0 ohm per centimeter. Actually, the density is given. The we can say resistivity 0.1 ohm per centimeter is given. The unknown resistance X is connected in the left gap and 6 ohm is connected in the right gap. The null point divides the wire in the ratio 2:3. Find the current drawn from the battery of 5-volt supply. So how it can be solved? At the left hand side, the unknown resistance X is connected. X. And the right hand gap is connected with 6 ohm resistance across the wire string of 1 meter length or 100 centimeter length. The null location is given, the 2:3. The ratio is 2:3 is given. Suppose this is L and this must be 100 minus L. Are you getting? So what is L upon 100 minus L? L upon 100 minus L is 2 divided by 3. That relation is given. And you have to find the current. And the bridge circuit is connected to 5 volt. The overall circuit is connected to 5 volt. Now you might be observed under the balance condition, there is no current flowing through the galvanometer. The current is 0. It means that X and 6 ohm are in series, isn't it? So first of all, you find out X. What is X? You apply the balance condition. X divided by L is equal to 6 divided by 100 minus L. Or X is equal to 6 into L upon 100 minus L. But L upon 100 minus L is 2 upon 3. It will be 6 into 2 divided by 3. So 3 2s are 6. So X is 4 ohm. What is X? X is 4 ohm. Now under the balance condition, this 4 ohm is in series with 6 ohm. And the length of wire is 100 centimeter. And the resistance of wire is given 0.1 ohm per centimeter. So what would be the resistance of the wire? The resistance of the meter wire, resistance of the wire is equal to 0.1 into 100 centimeter. The 0.1 into 100 gives 10 ohm. The total resistance of the 10 ohm is given. Now this 10 ohm resistance is in parallel with X plus 6, 10 ohm resistance. So equivalent resistance of the bridge circuit is 1 upon RT is equal to 1 upon 10 plus 1 upon 10 is equal to 2 upon 10 or 1 upon 5. So total resistance is 5 ohm. And this 5 ohm resistance is connected to 5 volt supply. I can simplify the circuit network. To look at the circuit network, the 5 volt supply is connected to the equivalent circuit of RT is equal to 5 ohm. And you have to find the current in the 5 ohm resistance. You may apply the Kirchhoff's voltage law. So current I is equal to voltage 5 volt divided by resistance RT. So 5 volt divided by 5 ohm gives 1 ampere. The correct answer is 1 ampere. So look at the option. The first option is 1 ampere, second 1.5, 2 and 5. But correct option is A, 1 ampere. So in this way you solve the example. The next example, let we see. The example is given as in the potentiometer. The example based on the potentiometer. In the potentiometer experiment, the null point is obtained at a particular point for a cell on the potentiometer wire x centimeter long. If the length of potentiometer wire is increased without changing the cell, the balancing length will be, what would be the balancing length? That we have to find. You know the potentiometer, how the potentiometer look like? You let me draw the diagram of the potentiometer. The simple diagram, which is not given in the book. The voltage supply, let's consider V. Voltage supply given to the potentiometer is V. It is given to the copper wire. This is your copper wire of uniform diameter. The length of wire, let's consider L. L will be the length of the wire. And let's consider R is the resistance of the wire. R is the resistance of the wire. In the potentiometer, null point is obtained at x centimeter. Isn't it? X centimeter null point मिळतो आपल्याला. इथे एक अननोन सेल इथे कनेक्ट करायचे. And it can be connected with the help of Jackie J. Now, if the length of the potentiometer wire is increased without changing the cell let's consider E, and the internal resistance is R, then what is the balancing length? आता इथे दोन कंडिशन दिलेल्या आहेत, त्यामुळे पहिल्या कंडिशन मध्ये हा L1 घ्या, इथे हा R1 घ्या, and the balancing location let's consider small L1. हा balancing location असणार आहे. And applied voltage is V. So first case मध्ये काय काय कन्सिडर केले बघा. Battery supply is V. Then resistance of the wire, the resistance of wire is R1. The length of wire is L1. And balancing length म्हणजे null point location जो आहे तो L1. The balancing length is small L1. That is the first condition. Now in the one more parameter is given, battery cell. The cell is E. E is not changing in both cases. E not changing. The battery cell is E connected across the L1. Are you getting? So under the balance condition, we will get this equation: E divided by V is equal to L1 divided by capital L1, where capital L1 is the length of wire, small L1 is a balancing length, E be the cell, and V be the battery voltage. This is your balance condition. E upon V is equal to L1 upon L1. Now second case. Now apply second case. In the second case, let's consider resistance wire. Resistance of wire is R2. The length of wire is L2, where L2 must be greater than L1. You check out the problem. If the length of potentiometer wire is increased without changing cell, it means the length of the wire is now L2 and L2 is greater than L1 always. The cell is E. These are the given, and the balancing length, let's consider small L2. Balancing length is small L2. And assume that the location of the jockey is at the null point. And under the balance condition, the equation is now E upon V is equal to L2 divided by capital L2. Now you can compare these two equations, the first equation and second equation. The first equation we got after applying the first case, and second equation is we obtain after applying the second case. Now you can check, the left hand side is same, E upon V, E upon V. So right hand side must be same. The right hand side is L1 divided by capital L1 is equal to L2 divided by capital L2. So what is the new location? The new location of the balance point. L2 is a balancing length. Length of second case. So we have to find the L2. L2 is equal to L2 capital L2 minus L1 multiplied by small L1. But condition is given L2 is greater than L1. It means the ratio L2 divided by L1 is greater than 1. As the ratio L2 divided by L1 greater than 1, small L2 is also greater than small L1. It means the balancing length will increase. It will not decrease. So option A is the correct option. Isn't it? If the length of the potentiometer wire is increased without changing the cell, the balancing length will increase because the length of the total wire is increased. So option A is correct. This question is very simple and it was asked in the MST CTA exam 2016. Let we move to the next example. Example number 9. A potentiometer wire of length 10 meter is connected in series with a battery. The EMF of a cell balances against 250 centimeter length of wire. If the length of potentiometer wire is increased by 1 meter, the new balancing length of the wire will be. आता हा जो एक्झाम्पल आहे तो पूर्वीच्या एक्झाम्पल सारखाच आहे. आता इथे बघा, इथे बॅलन्सिंग लेंथ किती आहे बघा मीटरमध्ये. इट इज 2.5 मीटर आहे ना. द टोटल लेंथ ऑफ वायर इज 10 मीटर and balancing length किती आहे 2.5 मीटर आहे. नाउ इन द सेकंड केस द वायर इज इन्क्रीज बाय 1 मीटर. आता वायर किती असणार आहे 11 मीटर असणार आहे. तर न्यू बॅलन्सिंग पॉइंट काय असणार, इट मस्ट बी ग्रेटर दॅन 2.5. इट मस्ट बी ग्रेटर दॅन 2.5 असणार आहे. म्हणजे आन्सर काय असणार आहे 2.75 असणार आहे. लेट वी सॉल्व. हे आपण सॉल्व करून बघूया. आता फर्स्ट कंडिशन मध्ये बघा, फर्स्ट कंडिशन तुम्हाला माहिती आहे व्ही डिवायडेड बाय ई इज इक्वल टू 2.5 म्हणजे 250 सेंटीमीटर बॅलन्सिंग लेंथ डिवायडेड बाय 10 मीटर, where 2.5 is what the balancing length. हे बॅलन्सिंग लेंथ आहे and 10 मीटर is the length of wire आहे, length of wire. And what is V? V is a supply voltage. V is a supply and E is a cell, battery cell connected to the potentiometer. So cell. आता काय केलंय सेकंड केस मध्ये विदाउट चेंजिंग व्ही अँड ई काय चेंज केलेलं नाही. द वायर लेंथ इज इन्क्रीज बाय 1 मीटर म्हणजे हा 11 आहे, हा 11 होतोय. तर न्यू लोकेशन काढायचं आपल्याला एक्स, isn't it? So this will be equation number 1 and this will be equation number 2. Compare equation 1 and 2. Left hand side is same, so right hand side must be same. So x upon 11 is equal to 2.5 divided by 10. So what is x? X is equal to 2.5 into 11 divided by 10. It is equal to 2.5 into 1.1, and 2.5 into 1.1 is 2.75 meter. So that is the answer. So look at the answer here, 2.75 is a correct answer. Or you can apply the logic, basic logic. If the length of wire increases, then the location of the balance point will also increase. As the location of the balance point or null point is given 2.5 meter, it must be greater than 2.5. So correct answer is 2.75 meter. Let we move to the next example. Example number 10. The 10th example is given. The resistivity of the potentiometer wire is 40 into 10 to the power minus 8 ohm meter given, and its area of the cross section is 8 into 10 to the power minus 6 meter square is given. If 0.2 ampere current is flowing through the wire, the potential gradient of the wire you have to find. Now what is the potential gradient? You know, if the length of wire is, let's consider L. Let's consider length of wire is L and potential across the wire is V. The potential given across the wire is V. Then potential gradient is, the potential gradient is defined as the change of potential with respect to distance. It is equal to V by L. Are you getting? The potential gradient is V by L. But potential is not given. The current is given. The length is also not given. But here you have to make one assumption. Let's consider the length of wire is 1 meter. Let's consider L is equal to 1 meter. 1 meter एक कन्सिडर करा लेंथ ऑफ वायर, दिलं नसेल तरी. त्यानंतर आता आपल्याला काय काढायचं, रेजिस्टन्स ऑफ द वायर. हाऊ द रेजिस्टन्स ऑफ वायर इज कॅल्क्युलेटेड? द रेजिस्टन्स ऑफ वायर of wire, let's consider R. R is equal to rho L, rho into L, where L is the length of wire and divided by A. A is a cross-sectional area, where rho is a resistivity. Rho is what? Resistivity of the wire. L be the length of wire, and capital A is a cross-sectional area. So all these things are given. So find out R. R is equal to rho. Rho is how much? The resistivity is given. 40 into 10 to the power minus 8. 40 into 10 to the power minus 8. The length of wire is 1 meter and the cross-sectional area is given. It is 8 into 10 to the power minus 6. 8 into 10 to the power minus 6. So 8 5s are 40. So this will be 5 into 10 to the power minus 8, and take this 10 to the power minus 6 at numerator, it become 10 to the power plus 6. So resistance of wire is R is equal to 5 into 10 to the power minus 2 ohm, or it would be 0.05 ohm. The total resistance of the wire is 0.05 ohm. And in this resistance, the current 0.2 ampere is flowing. The current flowing through the resistance R is equal to 0.05 ohm is 0.2 ohm. Then what would be the potential V across the resistance? The potential V across the resistance can be determined using Ohm's law. It is equal to I into R. So potential V is equal to 0.2 into 0.05. So R किती येते बघा, R is 0.2 into 0.05 gives 1 into or 0.01 येणार. Okay, getting 0.01 is a potential across the wire or resistance of 0.5, and the potential gradient is V by L. The potential across the wire is 0.01 multiplied by length of wire is 1 meter. So potential gradient is 0.01 or 1 into 10 to the power minus 2 volt per meter. So K is a potential gradient. Potential gradient. In this way, you find the potential gradient, and it must be 1 into 10 to the power minus 2 is the correct answer. So let us see the options. The first option is 1 into 10 to the power minus 1. You can read as a 1 into 10 to the power minus 1. Second option, 1 into 10 to the power minus 2. The second option is the correct option. Here in this example, the two equations are very important. The first equation is the equation of resistance R is equal to rho L by A, and second equation is a potential gradient. The potential gradient is total voltage divided by length of wire. With help of these two equations, you find out the gradient of the potential. The next example, the 11th example, it's very simple. It's based on the potentiometer experiment. In a potentiometer experiment, it is found that no current passes through the gallonmeter when the terminal of the cell are connected across 52 centimeter of the potentiometer wire. And if the cell is shunted by the resistance of 55 ohm, the balance is found when the cell is connected across 40 centimeter of the wire, Find the internal resistance. The two cases given. In the first case, let me draw the diagram of the potentiometer. This is your wire of length L. The potential supply is given. V is given here. And the battery is connected. Cell, we can say cell is connected. E. The cell has internal resistance, let's consider small r. And through the galvanometer, it is connected to the wire. And the null point is given, or balance length. The balancing length is how much? 52 centimeter given. Isn't it? Now, since the no current is flowing under the balance condition in the cell, I is equal to 0 in the cell. So voltage drop across the R would be 0. Isn't it? And under the balance condition, we'll get E upon V is equal to 52 divided by एक मिनट 52 divided by the total length. Let's consider total length is L. Are you getting? The total length of wire is L. 52 be the balancing length. E be the cell connected across the wire, and V be the supply voltage. So what is the relation for E to V according to the balance condition? E upon V is equal to 52 upon L. Is it right? Now the next condition is applied. Now in the next case, the shunt resistance is connected across the cell. इथे काय केलेलं आहे बघा, इथे एक मिनिट, इथे निगेटिव्ह पोटेन्शियल कनेक्ट करा. Negative positive. V is given. This will be negative positive internal resistance, and across the cell the resistor is now connected of 5 ohm, and then further it is connected through galvanometer to the wire. So this circuit is given, and the balancing length is also given 40 centimeter. Isn't it? Now how much current is flowing through the galvanometer? I is equal to 0. But this circuit is a closed circuit. The current will flow, let's consider small I, will flow through 5 ohm and small r. The same current will flow in the 5 ohm resistor, in the small r resistor, and the cell, battery cell. And no current will flow through the galvanometer. Now you have to find the current flowing through the cell. What is the current flowing through the cell? The current flowing through the cell is the cell voltage divided by 5 plus R, where this small r and 5 are in series because the same current is flowing through the wire. That's why these are coming in series. And then find the voltage drop across small r. Voltage drop across small r is equal to small r into I. The small r into I is R into capital E divided by 5 plus R. That would be the voltage drop across R. Then you have to find the voltage at this point. The voltage at this point is total voltage E minus voltage drop across R. तर इथं voltage काय येणार? The total supply voltage by cell is E minus R into E divided by 5 plus R, where R into E divided by 5 plus R is a voltage drop across R, is equal to E into 1 minus R upon 5 plus R. Again, you simplify it, it become E into 5 plus R minus R become 5 at numerator divided by 5 plus R. The voltage drop at this point is 5 E divided by 5 plus R. Yeah, and that voltage appear across the 40 centimeter wire. The voltage is 5 E divided by 5 plus R. And then apply the condition for balance. The voltage drop across the 40 centimeter wire or balancing length is 5 E divided by 5 plus R divided by V is equal to 40 divided by L. Isn't it? Now you can take the ratio to cancel E, capital V and L. After taking ratio, we get E upon V to this term. E upon V divided by E upon V into 5 divided by 5 plus R is equal to 52 divided by 40. E by E cancel, and we have the new equation. I could write here 5 plus R divided by 5 plus R will come at the numerator divided by 5 is equal to 52 divided by 40. It gives 5 plus or 40 into 5 gives 200 plus 40R is equal to 52 into 5. 40R is equal to 52 into 5 is how much? 5 into 2 is 10. 5 into 5 is 25, 26. 260 minus 200. 40R is equal to 260 minus 200 is 60. And what is R? R is 60 upon 40 or 6 upon 4 or 3 by 2 or 1.5. The internal resistance must be 1.5 ohm. Isn't it? The correct answer is option D. The internal resistance of the wire is 1.5. The next example. A voltmeter cannot be used to measure EMF of a cell, but potentiometer can be used to measure EMF of a cell because it's a very easy. Ask in the MST CT 2019. The example is given based on the voltmeter. The voltmeter cannot be used to measure the EMF of the cell, but potentiometer can be used to measure EMF of the cell because the potentiometer does not draw current from cell. Second option is potentiometer can draw current from a cell. Voltmeter does not draw current from a cell, and voltmeter is portable and compact. So what is the correct option? Option A is the correct because when the potentiometer is balanced, let me draw the circuit of the potentiometer. Here the cell is connected E with internal resistance R. Even the resistance R is connected in series with E. The voltage drop across R is zero under balance condition because there is no current. Under the balance condition, the current flowing through the cell is zero. Isn't it? No current flowing through the cell if the potentiometer is a balance. Under balance condition. And the magnitude of the cell can be measured under balance condition only. So current is zero in the internal resistance. The voltage drop across the internal resistance is zero. So that is the reason behind it. The potentiometer does not draw current from the cell. Is the correct answer. The potentiometer can draw current from cell is incorrect. कारण बॅलन्स कंडिशन मध्ये कधी करंट इथे फ्लो होत नाही. इथे झिरो असतो बॅलन्स कंडिशन मध्ये. गॅलनमीटर मध्ये करंट फ्लो होत नाही. त्यामुळे ऑप्शन ए करेक्ट आहे. The next example is a gallanometer having a coil resistance of 100 ohm gives full scale deflection when the current of 1 milliampere pass through the gallanometer. The value of resistance which can convert this gallanometer into ammeter of full scale deflection for current of 10 ampere is. तर गॅलोमीटरचा तुम्हाला इक्वलंट रेजिस्टन्स आणि त्याचा इंटरनल सर्किट तुम्हाला माहित पाहिजे. आता हे बघा पहिल्या कंडिशन मध्ये काय केलेलं आहे. इन द फर्स्ट कंडिशन द 1 मिली एम्पियर करंट इज फ्लोइंग थ्रू द गॅलोमीटर. Current is 1 milliampere is flowing. Let's consider the resistance of gallanometer is Rs, isn't it? And the current flowing through the wire through the gallanometer is Ig, and the Rs is 100 ohm. The resistance of the gallanometer is given 100 ohm. Then what will be the potential across the gallanometer or voltage across the gallanometer? The voltage is Rg into Rs. Voltage किती आहे ते 1 into 10 to the power minus 3 into 100. It gives 0.1 volt. Voltage किती मिळणार 0.1 volt मिळणार इथे या पहिल्या कंडिशन मध्ये. In the second case, one resistance is connected in shunt so that the gallanometer can be used to measure the maximum current of 10 ampere. सेकंड केस मध्ये काय केलेलं आहे हे बघा. गॅलनमीटर जो आहे हा 100 ओमचा रेजिस्टर आहे आरएस. इथे 1 मिली एम्पियर करंट फ्लो होतो. तर इथे एक शंट रेजिस्टन्स कनेक्ट केलेला आहे आर. का कनेक्ट केलेला आहे कारण मला टोटल करंट 10 एम्पियर मेजर करायचं आहे. कारण याच्यात मॅक्झिमम करंट किती फ्लो होतो 1 मिली एम्पियर फ्लो होतो. म्हणजे या रेजिस्टर मधून इन द गिवन रेजिस्टर आर शंट रेजिस्टर आर अप्रॉक्सिमेटली 10 एम्पियर करंट इज फ्लोइंग because 1 milliampere is very small compared to 10 ampere. तर इथे किती एम्पियर करंट फ्लो होणार 10 एम्पियर करंट फ्लो होणार. आणि व्होल्टेज किती आहे बघा 0.1 व्होल्ट आहे इथे. तर व्होल्टेज अक्रॉस गॅलनमीटर इज गिवन. व्होल्टेज अक्रॉस गॅलनमीटर इज 0.1 volt, isn't it? So voltage is equal to 10 into R according to Ohm's law. 10 into R is a voltage. This voltage is given. It's a 0.1 volt is equal to 10 into R. So R is equal to 0.1 divided by 10 is equal to 0.01 ohm. So how much resistance is to be connected in shunt? 0.01 ohm resistance should be connected in the shunt. The correct option is D. It's a very easy question. It was asked in JEE Main 2016. You do a practice, then only you can get the confidence. Overall, the problems are very easy. You have to apply your logic and IQ level to solve various examples. आता हे पण त्या टाइप मध्येच आहे. तर काय केलेलं आहे बघा. A deflection in the galvanometer falls to 1/4 when it is shunted by 3 ohm. If additional shunt of 2 ohm is connected to earlier shunt, the deflection of the galvanometer. म्हणजे पहिल्या कंडिशन मध्ये काय केलेलं आहे, if the total current is I, then the deflection in the galvanometer is I upon 4 असणार आहे. If the shunt resistance is 3 ohm. ही पहिली कंडिशन आहे. म्हणजे हा गॅलनमीटर आहे. या गॅलनमीटरच्या अक्रॉस जर 3 ओम रेजिस्टन्स मी कनेक्ट केला, इफ आय कनेक्ट द 3 ओम रेजिस्टन्स अक्रॉस द RS, then total current flowing through the resistance RS is I/4. आता सेकंड कंडिशन काय दिलेलं आहे बघा. द 2 ओम रेजिस्टन्स कनेक्ट केलेला आहे. इथं काय केलेलं आहे, हा RS, हा 3 ओम आहे आणि इथं 2 ओम दिलेलं आहे. हे 2 ओम. तर इथे करंट किती असणार आहे तो काढायचा आपल्याला. हा करंट, लेट कन्सिडर IS और IG घ्या इथे. द करंट फ्लोइंग थ्रू द गॅलनमीटर, तो फाइंड आउट करायचा. तर पहिल्यांदा हे आपल्याला फाइंड आउट करावं लागेल. आर किती आहे, हा RS किती आहे तो फाइंड आउट करावा लागेल. आता इथे करंट डिवायडर फॉर्म्युला यूज करायचा. आता बघा, द करंट फ्लोइंग थ्रू द RS किती आहे, I/4 आहे. तर इथून ह्याच्यामध्ये करंट किती फ्लो होणार आहे, 3I/4 फ्लो होणार आहे. कारण टोटल करंट किती आहे, I आहे. I/4 plus 3I/4 gives I. Are you getting? So current in 3 ohm is 3I/4. 3I/4 is the current flowing through 3 ohm is equal to, हे कसं काढतो आपण, the total current I multiply by opposite resistance RS divided by RS plus 3. Sum of resistances which are connected in parallel. 3 आणि RS एक आहे, पॅरलल मध्ये आहे, त्यामुळे इथं समेशन घेतलेलं आहे. आणि हे सगळं सॉल्व्ह केल्यानंतर काय होणार बघा, हे I आणि I जाणार, कॅन्सल होणार. आणि सिंपल आहे एकदम सॉल्व्ह करायला. त्याचा आन्सर येणार आहे 9 ओम येणार हे सॉल्व्ह केल्यानंतर. म्हणजे आपल्याला काय मिळालं इथे, RS 9 ओम मिळाले इथे. आता 3 पॅरलल 2 किती येते बघा, त्याचा इक्वलंट रेजिस्टन्स किती येणार, 3 पॅरलल 2, 3 into 2 divided by 3 plus 2 is equal to 6/5. म्हणजे मी once again I draw the circuit. The total current is I. The current flowing through the RS of 9 ohm, we have to calculate IG, and the shunt resistance is now 6/5. 5 आहे, 6/5 आहे. And you have to find IG. Use the current divider formula. IG is equal to the total current I into opposite resistor is 6/5. 6/5 divided by sum of resistors, 9 plus 6/5. You solve this one, you will get I into 6/5 divided by 9 into 5 is 45. 45 plus 6 is 51 divided by 5. So Ig is equal to I into 6 divided by 51, or I into 6 8s are 48. रिमाइंडर किती असणार आहे 3, म्हणजे 6 5s are 30. So it will be I divided by 8.5. So after connecting the 2 ohm shunt resistance, the current will drop by 1 upon 8.5 reflection. The correct answer option D असणार आहे. Now we'll solve the last example. The last example is also based on the gallon meter. The voltmeter दिलेलं. Voltmeter has a resistance of G ohm and the range V volt, and the value of resistance required in series to convert it into the voltmeter range NV दिलेला आहे. बघा व्होल्टमीटर कसा असतो, एक रेजिस्टन्स असणार आहे, त्याचा रेजिस्टन्स जी दिलेला आहे, and the current flowing through the voltmeter, let's consider Ig, and what is the potential across gallon meter according to Ohm's law, it will be Ig into G असणार आहे. The voltage is Ig into G. Now in the next case, the resistance is connected in series to convert the voltmeter range to NV. सेकंड केस मध्ये काय केलेलं आहे, एक आणखी एक रेजिस्टन्स जी मध्ये ऍड केलेला आहे, आणि करंट याच्यातून किती फ्लो होणार आहे, आयजी फ्लो होणार आहे. हे कशासाठी कनेक्ट करतोय आपण, कारण त्याचं व्होल्टेज रेंज एन इंटू व्ही मध्ये कन्वर्ट करण्यासाठी. तिथे काय येणार, एन इंटू व्ही इज इक्वल टू आयजी इंटू आर प्लस जी येणार इथे, कारण आर आणि जी हे काय सिरीज मध्ये आहेत. Are you getting? So N into V is equal to Ig into R plus G, or we can say V is equal to Ig into R plus G divided by N. Now you can compare these two equation, equation 1 and equation 2. आता equation 1 and 2 मध्ये लेफ्ट हँड साइड सेम आहे, सो राइट हँड साइड पण काय असणार आहे, सेम असणार आहे. So right hand side can be compared from equation 1 and 2. It will become Ig into G is equal to Ig into R plus G divided by N. Ig from both sides will be cancelled, and the resistance become Ng is equal to R plus G, and R is equal to Ng minus G, or it will be G into N minus 1. The new resistance is G into N minus 1 असणार. कुठला असणार बघा, हा सिरीज मध्ये G into N minus 1 हा करेक्ट ऑप्शन असणार. अशा वेगवेगळ्या पद्धतीने तुम्ही एक्झाम्पल सॉल्व्ह करू शकता. बिकॉज ऑफ द टाइम कन्स्ट्रेंट, it is not possible to solve all the examples, but similar example can be asked in the exam and you can solve it. If 3 to 5 questions, 3 to 5 equations regarding potentiometer, galvanometer, voltmeter, and the Wheatstone bridge are known. So thank you for patience listening this lecture. With this, I conclude this lecture. So thank you very much. Vishal sir.
हा सर.
हा, स्टॉप करूया का?
हा करूया ना.